Continuing on with 2.6, this is the Bell problem. How is the function related to y equals x? If you notice, we have nothing different with our x term, but we have something added or subtracted at the end. Since it is added or subtracted at the end, that means we're going up or down. And since it is positive, that means we're going up. So how are the functions related? We went up 4.5 units. We're going to talk about a different type of transformation, which is a reflection. A reflection in the y-axis, meaning if we look at our first function here in black, we're going to reflect it over the y-axis and get the function in green. When you reflect a graph in the y-axis, the x values change signs and the y values stay the same. So if you look at the points here, we have the point 1, 1. When we reflect it over, again, the x value changes signs and the y value stays the same. That's true for every point on this function. When reflected in the x-axis, the x values stay the same and the y values change signs. So if we start with the function in blue, we reflect it over the x-axis, start with the function in black. When we reflect it over the x-axis, we get the function in blue. Again, your x values stay the same, your y values change signs. So when you're reflected in the y-axis, your y values stay the same. And when you're reflected in the x-axis, your x values stay the same. So that should be easy to remember. Our first example, let g of x be the reflection of f of x equals 3x plus 3 in the y-axis. What is the function rule for g of x? So that means we need to write our new function rule. And when we reflect it in the y-axis, remember, that means we are changing only the x terms, so they change signs, and we don't change any other terms, so that's going to equal our g of x. So when we plug this into our equation, we look at our f of x equation, and whenever we see an x, we change it to negative. So it'll be 3, I see an x, so it's going to become negative x, plus 3, since the plus 3 has no x, that stays the same. So our function, g of x, is 3 times negative x is negative 3x, and our plus 3 at the end stays the same. So it's pretty simple. Again, when reflected in the y-axis, your y values stay the same, and your x values change signs. Same thing goes when reflected in the x-axis, our x values stay the same, but our y values change. So we have h of x, and when we're reflected in the x-axis, that means we are changing every term sign. So we have negative f of x. So we're going to take our f of x function, we're going to put a negative out front. We still keep 3x plus 3, but to get our final function rule, h of x, we have to distribute through that negative. So negative times 3x is negative 3x. And negative times 3 is negative 3. And our function rule is h of x equals negative 3x minus 3. So the table below represents the function f of x. What are the corresponding values of g of x for the transformation g of x equals 3 times f of x? Okay, so they already give us the values for f of x, and we have to figure out the values for g of x. All we do, since it's being multiplied by f of x, 3 is, all you do is take your f of x and multiply those by 3. So we get 6, 6, negative 9, 3, and negative 6. Now if I asked you what was the transformation performed on these two functions, since the number is out front of our x term and it's greater than 1, this would be considered a vertical. Remember, we have vertical stretch or we have vertical compression. Since it is not a fraction, it will not be a compression. Remember, compression, fraction, ION, ION. So this is a vertical stretch. Again, since the number is greater than 1 out front of our x term. So pretty simple. So these are the different types of transformations we have talked about. Again, if you look the vertical translations, we are adding or subtracting something that is not grouped with our x. If it is added, we move up. Subtracted, we move down. Horizontal, again, look, that is grouped with our x term. If it is minus, we move right, and plus, we move left. You got to think opposite for that. And then we have our stretch and compression. Again, the number is out front of our x term. If it's greater than 1, it will be a stretch. If it is less than 1 but greater than 0, it will be a compression. Again, fraction, compression. A fraction has to be less than 1 but greater than 0. And then we have our reflections. Remember, reflection in the x-axis means our x values stay the same, our y values change signs. And the same thing for y. If we have reflection in the y-axis, our y values stay the same, our x values change signs. So if we look here, the graph of g of x is the graph f of x equals x. It is stretched vertically by a factor of 2. It then translated down 3 units. We have to figure out the function rule for g of x. So we have g of x. I can write it here, g of x. And since it is a vertical stretch of 2, that means our number goes out front of our x term, and our x term is just x, so we'll have 2x. And then since we are translating down 3 units, since we're going down, it's going to be minus, and it's going down 3. Again, it won't be grouped with x because it is translated down, so we're moving our y values down 3. We'll be working on this worksheet tomorrow. Come prepared, ready to work on it.